Hey guys, Laird here and welcome to my next video in the Lightsaber combat tutorial. So today we will start talking about line tracing. And as you remember from our previous tutorial, if we hit play and we start swinging our lightsaber, after some time the character will get back to the normal idle position. And that was the previous tutorial, and in this one let's do some ray tracing or ray casting. I'm not sure what is the right word because there is a confusion. Well, there could be a confusion between the technology which is used to render stuff, which is ray tracing or path tracing, and the kind of ray casting that we will do, which will be on CPU instead of GPU, and we'll be using it to actually kind of try to understand what hits the lightsaber, or what is the thing that lightsaber is hitting at any point in time. And today we will just start this thing. So first thing we will do ray casting every tick. So for example 60 times a second. Sometimes it's not the best for performance, but let's just do that. Let's see what we can do. Maybe we can spawn some effect when the lightsaber hits something. And let's just go ahead in our lightsaber class here and let's get a tick event. So event tick, already have it, it does some stuff. To keep your code more or less tidy, let's make a sequence here. And let's just start organizing our code base. So this thing is related to extend / hide the blade. And I usually prefer having my comments black. And you can see here you can also change the text size, many other stuff. So this is the first thing we are doing. And then you can do, of course, minor stuff which kind of cleans up the look of the code by, for example, getting rid of multiple lines going from the same variable, stuff like that. But I'm not gonna care too much about this right now, so this is clean enough for me. And then we do next thing. So every tick we're gonna trace. So let's find our line trace. And let's do it by, let's start by channel, and the channel will be, okay, let's do visibility for now. And now we need the start and the end coordinates in the world space. Now we never know what's actually, we don't have this information kind of handed to us, which is, you know, when does the blade start and when does the blade, at which point the blade starts and the blade ends. Or do we? Well, actually, let's look at our blade. It's a cylindrical shape, so let's go ahead and come here. And we see that it has one socket, which is a middle socket. Let's make two more. Let's make a base socket. And let's place this base socket at -50, or oh, actually it's 0. Yeah, so 0 is the base of the cylinder, as we can see, because that's the origin of the cylinder center. So make sure you have 0, 0, 0 here. Let's make another one. Basically, we don't need base because we can just say that, you know, take the world location of this component. But let's keep it kind of clear as to what we are doing. So we have a base, and let's make another one, which will be tip. And tip will be like this. And it will be on the 1 meter distance from the base. And the reason for this is that, of course, the cylinder, the standard Epic cylinder, which comes with the starter content, it has dimensions, such dimensions that its height is 1 meter. Now, the reason why we're doing this, guys, is that, as you can recall, our cylinder extends when we are turning on the lightsaber, and it goes back when we're turning off the lightsaber. Now, the cool thing about sockets is that they follow the cylinder scaling. So the tip will be always in the tip, even when we make the cylinder longer, which is really handy. Okay, so now, where is the start, where is the end? Well, let's take the blade guy. Let's do get socket location. And the start will be in the base, as you remember. And then the end will be at the tip. Quick quick note for you guys. For now, I'm actually changing the cylinder in the starter content. I would not, what I'm doing is I'm adding the sockets here. I would not recommend doing that though. What I would recommend doing is duplicating it to your folder and then actually adding these sockets and using your own duplicate of the cylinder. And the reason for this is that imagine that in next version or at some point you will re-import starter content and all the stuff that you made on your cylinder will be just erased. So we don't want that. So let's get this socket location and this for end one. Keep in mind socket locations are in world space, so we don't have to do any transforms here. And let's draw the debug for duration, and duration will be, let's do like 0.5, ignore self. Okay, so now we're just tracing every tick. So let's see what happens. And you can see that we're doing exactly what you would expect. Maybe the trace is not visible that well on the camera. I think we can change that. Trace color is green. Okay, let's do something more clearly visible. Let's do green here, or maybe let's do blue. And as you can see, it works as you would expect. So now the next thing you want to do is let's at least start getting information about what we're hitting. So go ahead and branch out, and this return value will return, is it a hit? Is there a hit? So we can get out hit and just break hit results. We get kind of like a lot of information about it. Location, impact, all the stuff. So let's understand what is the hit actor. So print string hit actor. Now if you take an actor pin and you connect it to a string, we'd actually go ahead and take display name of the actor, which is really handy for this kind of simple situations. And let's see, we don't get anything, and we get a wall, which is really nice, precisely what we need. Okay, so now that we have this situation going on, I'm going to quickly talk to you about different types of traces here, just so you can experiment with this by your own. Now line trace, of course, is the simplest one, and we have different shapes here. So box, capsule, multi-box. Actually, I'll talk about multi later on. So box, capsule, line, and sphere are the shapes that we have, and these are the traces of different geometrical shapes, of course. So it's similar to collision primitives, right? You have capsule collision, which has its own shape, you have box collision, and so on and so forth, sphere collision. Now, multi traces are different in the sense that it can trace even after hit. This trace, line trace, box trace, and other traces without multi in the beginning of their names simply mean that they hit something and the trace ends and delivers information. Now when you do multi-trace, let's say multi-line trace, you can see that it returns actually an array of hits for everything that it hits. So if it hits the first thing but there is more stuff before it reaches the end, it will do more. It will go forward and it will read all other hits. Now traces come in flavors of line trace by channel, profile, and objects. Now these differ slightly. We will not go too deeply into this thing right now. We will study this later, maybe in later tutorials, if the need arises. But for now, let's settle on channel and visibility channel. And visibility basically tries to mimic of what we see. So the walls obstructs visibility, and it's really easy to see that. If you go into details on the wall, which I selected, which is a static mesh, you go into collision. Let's say we have a custom collision. So you can see that trace response visibility is blocking. So whatever blocks will be hit for our trace. Let's go back to default. Most solid stuff blocks visibility trace channel. So you can do your own collision channels and many other things. We will not go there now. But for now, let's try doing something with our information that we hit something. So let's bring up another content browser. Let's say the second one. and I have it here. Let's go to particles. We don't have anything here, or let's reset filters. Okay, we have our own particles, but let's go to starter content, and we have sparks here. Now you see I have this sparks. I just brought it up here, and this is default starter content spark from Unreal, and we're gonna use it. But the problem with this, of course, is just it keeps going. We don't need this. We want to spawn the spark when we hit a wall, for example, and that's it, right? The spark should just go off and destroy itself. So once again, I'll show you kind of the way how I would work with this. I go ahead, copy, and then copy here. So I carry drag and drop here, and it's copied. Let's say P lightsaber sparks. Well, we don't do P here, so we just do lightsaber sparks, case of naming. And so I have a duplicate of this guy, and the reason why I duplicated it, because I want to just make it one-time thing. So for each of those emitters, I go emitter loops 1, 1, 1. So it's gonna be like this. It's not exactly what we need. So one thing we could do is we could do like 0.25, 0.25, 0.25. So still not perfect. What we want ideally is we want to change this to let's see. We have a situation when it kind of spawns sparks for 250 milliseconds. We want to just make one burst. So instead of doing this rate thing, let's do burst thing. So let's put here 0 burst list, 0th element in a burst list, and let's make a count of like 500. Boom. So it's a one-time burst, so looks quite extreme. Okay, so let's change a couple of more stuff here. First of all, let's remove the constant acceleration. Well, actually, okay, let's keep constant acceleration. Well, let's use sphere velocity scale. Let's do like, I know what I want to change. Let's do this like 5 and put here hundreds. Now the bigger the radius where the sparks will spawn for the sphere. And velocity scale, the bigger it is, of course, the more sparks are affected by velocity. But still, I think there are too many of them, so let's go back here and do like 100. I'm not explaining, sorry for that, I'm not explaining to you guys what exactly are these parameters doing. And we will maybe go into detail with particles in another video. But for now, let's just try to tweak this stuff. So yeah, negative Z, let's enable all of these guys. Boom. I think this is good enough, I think, for now. So lightsaber sparks saved, find it here. And now when we hit, let's do spawn emitter at location. Don't think this will be what we need, but let's see. And the location will be just a hit location. So this hit result returns the location in world space, exactly what we need. Just fine, scale 1. And let's do one trick I'll show you. Let's do literal, well actually let's do random float in range. So you can see we have a scale of 1 by default for this sparse. Let's do a little bit randomization. So let's do from 0.5 to 0.9 maybe. And if you connect float to vector, it will just convert it, which means that this same value will be for x, y, and z, which is exactly what we need. We need uniform scaling. Okay, so we got that thing going, and let's try playing this thing. Okay, so here's the cool thing, of course. Our sparks are hitting, are just flying out of the wall all the time that our lightsaber is in the wall, which is kind of what we need. Let's tweak a couple of parameters before we go. Let's change the radius to maybe 2, 150. Let's do 150. And then the color, let's just hard code the color here. Let's see, constant curve, expand all. Okay, so here we have this. Let's do like green. Let's do like 50 green, 0 on other guys. No, that's not green, sorry. Let's do like that. And the same goes here, 50, 0, 0. I'm afraid that this guy is not gonna glow because I wanted it to glow. Okay, yeah, it will glow. Okay, that's nice. So it goes to 100. Let's say it goes like this. Let's try that. Boom. Yeah, that's, well, it's not exactly what I would call good looking. But before we go, let's remove the tracing. And keep in mind, guys, if you wanna, for example, regulate this change these parameters globally for the lightsaber, you can just promote it to variable. Let's say debug draw saber trace, right? You just have it as a variable. It could be public variable, right? And okay. Let's just, oops, sorry for that. We have our thing here, and our thing works. And we're hitting the wall and we're getting all these sparks and even some nice, what do you call this? Heat coming out of it, I think. Okay, of course this is excessive. You want to decrease the number of sparks and so on and so forth, but this is like the super basics of line tracing, using light tracing for some nice effects. Of course, ideally you would want to do this for more than just visual stuff, like inflicting damage and other things like that. And we will talk about this next video, or maybe a video after next video. So thank you for watching. Like, comment, subscribe, and see you next video. Bye bye.